Okay, and welcome to one of Miss Lawrence's favorite topics, section 3.3. We are going to be completing the square. Today's one of those days where you're like, Miss Lawrence, why didn't you teach us this eons ago? It would have made life so much easier. But we get to learn about it today. So I'm actually going to go ahead. I'm going to start with, can we solve this quadratic? And I'm going to say, okay, x squared minus 22x plus 121 is equal to 8. Now, normally when we'd solve this is that we would make it set equal to 0 and go from there. But if we can notice this, is that what's special about this quadratic and that trinomial is that it is a perfect square trinomial. And what's so cool about that is that it actually factors into x minus 11 squared. Now from here, this is kind of a different way of solving it, is that we can now solve by square roots because we have a square that's isolated. So we have x minus 11 is equal to plus or minus 2 root 2. So my last step is to add 11. So x is equal to 11 plus or minus 2 root 2. And that was a lot easier way of solving than setting equal to 0 and trying to factor and all of that stuff. So let's go ahead and say, well, what would happen if that wasn't a perfect square trinomial? What would we need to do? So we're going to start with our example and we will put steps as we go. We're going to have 2x squared minus 20x plus 14 equals 0. And from here, of course, you could say, well, I'm going to try and factor. There's a bx term, so we can't solve by square roots yet. And this is where this completing the square comes in really handy. The first step is that you want to make your leading coefficient, so make a 1. Meaning that you're going to have to divide everything by a. Now, this might leave you with some fractions, but fractions are okay. I have set this one up to be nice and easy for us. So this is x squared minus 10x plus 7 is equal to 0. Now, your next step is going to be to move your constant, so move c to the other side. Other side. So we are going to subtract 7, and I'm actually going to ask you to leave a space here. So x squared minus 10x, leave a space, is equal to negative 7. And here's the most important part. This is the completing the square part. Is that we are going to add half of b, so b over 2 squared, to both sides of the equation. All right, so for us, b is negative 10. So we're going to add negative 10 over 2 squared. And you, of course, need to do that to both sides. And, of course, when you're squaring something, it always ends up being a positive number. So for us, this ends up being x squared minus 10x, and negative 10 over 2 is negative 5 squared is plus 25. So negative 7 plus 25 here is equal to, we'll just write that out and we'll write 18 on our next one. So plus 25. All right, then of course we're going to go ahead, we're going to combine those like terms on the left side. But we also need to factor our perfect square trinomial. So the whole reason that we added this half of b over 2 squared is to make it into this perfect square trinomial that factors so nicely into x minus 5 squared. And negative 7 plus 25 is 18. So we're good on that one. Now from here, it's easy to solve for x by square roots, because you have a square that's isolated. So you take the square root of both sides. So we have x minus 5 is equal to plus or minus, this is going to be 3 root 2 when we simplify it. Add 5 to both sides. So our final answer here is x is equal to 5 plus or minus 3 root 2. And that is our final answer for this guy. Oops, I don't like that. Final one. So it's so nice. And as you get the habit of completing the square, it actually works a lot better and just has a little bit more of a better rhythm to it than other ways that we solve quadratics. So I'm going to go ahead and what I'm actually going to ask you to do is I'm going to ask you to pause the video and try this one on your own and then press play and see if you did it correctly. So example 2 for us is going to be x squared plus 8x minus 5 is equal to 0. So you can go ahead and press pause. And we're back, hopefully, together with us. Now, if you'll notice, step number 1 is already done for us, right? A is already 1. So step 1, check. Now we have to move C. So we're going to add 5 to both sides. X squared plus 8x, leave a space, is equal to 5. Now this is the part where we add 8 over 2 squared to both sides, which is 4 squared is 16. So that when we factor, this turns into x plus 4 squared is equal to 5 plus 16. That's going to be 21. Take our square roots. We get x plus 4 is equal to plus or minus square root of 21 cannot be simplified, minus 4. Final answer on this one is x is equal to negative 4 plus or minus the square root of 21. Hopefully you did pretty well on your own on that one. All right, so of course solving by square or completing the square is fun and easy to use, but here's the part where you're like, Miss Lawrence, this would have been so helpful in chapter number 2. That is that we can use completing the square to find our vertex form from standard form. I don't have room. All right. So you might have an equation. We are on example 3 here. You might have an equation that's something like y equals 3x squared plus 12x plus 18. Now, it's the same steps that we did before, but when you divide by a, you're going to have to notice that you're going to have to go back and multiply by a at the end. So those first steps is that we're going to divide every term by a. So we're going to make that leading coefficient 1. So this now turns into y over 3 is equal to x squared plus 4x plus 6. The second step is to move c. So we're going to subtract 6 from both sides. You still keep that y over 3, so y over 3 minus 6 is equal to x squared plus 4x, and we have to add that, we'll choose a different color for this, choose this blue. We have to add half of b squared, so this is plus 4 over 2 squared. 4 over 2 is 2 squared, so this is going to be plus 4. All right, so now, and I should have left a bigger space there so that we could have written that in. This turns into y over 3, negative 6 plus 4 is minus 2. And we're going to factor this one, which if you notice with factoring, it actually just turns into x plus half of b, and then you square that. So this is x plus 2 squared. And now we're going to go ahead, we're going to isolate y. So we're going to add that 2 over again. So y over 3, that's a y, is equal to x plus 2 squared plus 2. But here is the really important part. Let me even highlight it for us, is that remember to multiply every term by that a value. So we divided by 3 before. Now we need to multiply everything by that 3, so by this 3 down here, to make it disappear. I even switched colors so that we can see. So we're going to multiply here by 3, this one by 3, and the 2 by 3. So that 2 is where a lot of us kind of fall off and make a mistake. So our final answer here is y is equal to 3 times x plus 2 squared plus 6. And we can easily see that our vertex is at the point -2, 6. And from there, we use completing the square to turn our standard form into that lovely vertex form, which is super easy to graph because we can find our vertex and our stretch. All right, once again, I'm going to challenge you, and I'm going to ask you to try this one on your own. So example 4, I think I'm on. Double check. Yeah, example 4. Feel free to pause and try it on your own and then press play, just to challenge yourself. See how it goes. So y equals -2x squared minus 16x minus 6. And you're going to turn it into vertex form. Okay, so we need to divide every term by that -2. Watch your negatives here. So we get y over -2 is equal to x squared. This is now plus 8x and plus 3. All right, subtract your 3 over. So y over -2 minus 3. I'm going to leave a bit of a space so that I can add in that new constant. And our new constant here, switch to the screen, is going to be, we have 8 over 2 squared. 8 over 2 is 4. 4 squared is plus 16. You'll notice I usually like to write the number on the side that I'm combining like terms, because it doesn't really matter on my factoring one, because when I factor, so this is now plus 13, when I factor this, it just turns into x plus half of b squared. Subtract 13, so we get y over -2 is equal to x plus 4 squared minus 13. And now's that really important part. We need to multiply every term and watch your negatives, because that's not going to turn into a positive at the very end. So we have final answer, y is equal to -2 times x plus 4 squared plus 26 on that last one. So plus 26. And we love this because we can easily see, hey, my vertex is at the point -4, positive 26. Don't we love that? Isn't that nice to see? All right, one more challenge for you, and then you're done with these notes, I promise, is that from this form, it's actually pretty easy to solve. So from your vertex form, and we can just solve by setting equal to 0. So 0 is equal to -2 times x plus 4 squared plus 26. And the reason that it's easy to solve is because you just have to end up using your square roots. So divide by a -2. 13 is equal to x plus 4 squared. Take the square root of both sides. So plus or minus square root of 13 is equal to x plus 4. Subtract 4. So our final answer here is x is equal to -4 plus or minus the square root of 13. I don't know why I flipped it around, but I did. And there is our roots as well as our vertex. All right, great job, everyone. That was my favorite, and I will see you very soon.